all of you. Today I am going to discuss about a prism formula. Before that, you just have a look on this diagram. So this is about the analysis of year 2019. How many questions are easy? Easy 47%, medium 47%, difficult only 6%. So only 6% questions will be difficult questions here, remaining are easy. This is a pie diagram of that. So from first year you are getting 49% and from second year getting 51% of the syllabus. Now you just have a look on this: mechanics, heat, SHM, electrodynamics, optics and modern physics and electronics. So optics, if you observe, which is in yellow color, it is going to have an 11% of the weightage in the NEET syllabus. Okay, so today I am going to discuss one important topic in that is ray optics. Now let us have a look on this. This is a mark analysis of heat chapter. Heat is nearly, we can get 5 questions from heat, so therefore 20 marks. Oscillations will get 2 questions, wave motions will get 2 questions, ray optics possibility of 2 questions is there, wave optics possibility of 2 questions from that chapter, and work power energy also 2 questions will be coming. Semiconductors 2 questions, 8 marks. Electrostatics 2 questions. Current, electricity, that is electric current, okay, 8 marks. So today I am going to discuss about a prism. So this is a very important topic, because previously in 2018 you got one question regarding to this this concept prism. Okay, so I am going to discuss about that question here. After explaining the basic concept of the prism in a very easy method, I am going to discuss this previous year problem. It was a 2018 NEET problem. If you want, you can go to previous year problems book and check it. This was the problem given in the previous years. But before going to that, you have to know a basic concept of a prism, which I am going to discuss within 5 to 10 minutes. That's it. I am not going to take more time. You just have a look on this. Okay, so today, if you observe, this is prism A, B, C. It's a triangular prism. In this triangular prism, light ray is entering. These are the normals N1 and N2. These normals, if you consider N1 and N2, which are drawn perpendicularly, so they are drawn perpendicularly. One light ray enters PQ and it bends towards the normal. It bends towards the normal. This is the normal. Light ray enters like this. Actually, light ray has to pass like this. Because of denser medium, this is glass and this is going to be air. When light enters from air to glass, it bends towards the normal, and when it enters from glass to air, it bends away from the normal. This is a normal, it is away from the normal. So just see here, this is a normal. When light ray enters from air to glass, it bends towards the normal. It is the normal, it is bending towards the normal. And when light ray enters from glass to air, it bends away from the normal. You are observing this is going to bend away from the normal. So this is angle of incidence and this is angle of refraction. And this is angle of refraction. This is angle of emergence. You can call it as angle of emergence I2. This is angle of incidence. And this is called as angle of a prism, or refracting angle of a prism also you can call it. So light ray is entering PQ, it is suffering refraction again, it is suffering refraction once again, so it's coming out. So as the light enters from rarer to denser, its speed will decrease, that's why it is going to bend. Again its speed will increase, again it is going to bend. So change in speeds creates deviation in the prism. So the light ray actually has to pass like this, but it is going like this. This is called as deviation. Okay, so deviation I am representing with a small letter delta. So if you observe, light ray is entering and getting bended out here. So what is the first step you have to observe? I'm going to explain this concept in only just 3 steps. If you observe, the first step is you just consider triangle QUR. If you observe, you can write R1 plus R2 plus U is equal to 180 degrees. Okay, this is called as angle sum property. Angle QUR, R1 plus R2 plus U is equal to 180 degrees. Okay, so you can consider this as equation number 1. Now, if you consider here triangle TQR, if you observe, what are you going to see here? Delta is equal to I1 minus R1 plus I2 minus R2. Okay, so what is it? here exterior angle is equal to sum of interior opposite angles. Okay, so exterior angle, what is exterior angle? Delta is going to be exterior angle. These two are interior opposite angles. How is it? It is like this. Okay, this is exterior angle, this is I1 minus R1, and this is I2 minus R2 here. So here this is I1 minus R1, I2 minus R2. So exterior angle is delta, interior angles are these two if you observe here. So I am going to write exterior angle delta is equal to sum of interior opposite angles. This is step number 2. This is going to be step number 1. Then what is the next step I am going to consider here? Okay. So if you observe here, the third step I am going to write here is third step. What is the third step? You can consider in a quadrilateral. Okay, so this is in a triangle. In a quadrilateral AQUR, if you observe this quadrilateral AQUR, what are you going to see here in this quadrilateral? So here angle A, if you write that angle A, if you write angle A plus angle AQU plus angle U plus angle ARU. This is completely going to be 360 degrees according to the property that sum of the angles in a quadrilateral is equal to 360 degrees. That's why I'm writing here. So what is the angle? This angle plus this, completely this angle and this angle and as well as this angle going to be 360 degrees. If you observe here angle A, angle AQU, as you have drawn the normal, that is going to be 90 degrees. So plus U plus angle ARU is also going to become 90 degrees, that is going to be 360. So I can write this as A plus U is equal to 360, 90 plus 90 is 180, I can write minus 180. So A plus U is equal to, I can write it as 180 degrees. Okay, so I am going to write it as 180 degrees. Let us see what is going to happen. This is the third step here. If you observe the third step and the first step, you can write the first step like this. R1 plus R2 is equal to 180 minus U. Okay, so R1 plus R2 can be written as 180 minus U. And you can also write A plus U is equal to, here, this A plus U is equal to 180 degrees given here. You can write A is equal to 180 minus U. This is equation number, you can write it as 3, you can write it as 4 here. So 3 is going to be equal to 4. So what are you going to write now? If you compare this, you can write R1 plus R2 is equal to A, because 3 is going to be equal to 4 here. Because here right hand sides are going to be same. So R1 plus R2 is going to be A. You can consider this as a very important identity that is taken as 5 here. So this is very important while solving the problems. The next thing which I am going to discuss is, if you observe here and here, the second step is delta can be written as I1 minus R1 plus I2 minus R2. It is given here. So what are you going to write now? This can be written as delta is equal to I1 plus I2 minus of R1 plus R2. You can write like this. Okay. So what are you going to do now? So delta is equal to I1 plus I2 minus A. Why is it so? Because R1 plus R2 we have taken it as A here. So therefore I can write this as I1 plus I2 is equal to A plus delta. So this is very important identity which is used in the solving the problems. So this is equation number 6 here. So these two are very important for us. These two are very important identities because these are used while doing the problems. Next that comes is, what do you mean by angle of minimum deviation? So to understand the angle of minimum deviation, we have to go towards the screen now. Okay, so let us see what is happening here. So observe here. Okay, so if you observe this graph here, so in this graph you are seeing that angle of deviation and angle of incidence is taken here. Angle of deviation and angle of incidence is taken here. If you go on decrease the angle of incidence from 50 to 40 to 30, what are you going to see here? Angle of incidence first increases okay, and then it is going to decrease here. Let us see what happens here. So if you observe this graph and slowly increase the angle of incidence, so if you slowly increase the angle of incidence from 0 to 20 to 40 to 60 to 80, you will observe that first angle of deviation decreases and then increases. What is the meaning of this graph? Let me discuss here. Okay. So there is one experiment which you are doing in second year. If you slowly increase angle of incidence from 0 to 20 to 40 to 60, you will observe that angle of deviation is first decreasing to a certain extent and again increasing after that. So if you observe here, there is one point which is called as minimum, and that is called as angle of minimum deviation. At angle of minimum deviation, you will observe that the point is going to touch at this place where I1 equal to I2. Why I am writing like this? Because at different angles, like 50 if you consider, if you draw a line here, this is going to be I1 and this is going to be I2. Whereas at different angles of deviation, for example, if deviation is going to be 40 degrees, then you are going to see that I1 equal to I2. At some other angle like 50 degrees, angle of deviation, if it is 50 degrees, you will see that angle of incidence and angle of emergence are going to be different. This is different here, it is nearly some 30, 38 like that. And if you observe the other angle, it is above 60 degrees and below 80 degrees, maybe nearly 70 degrees. So this can be some 38 and this is 70 degrees, let us consider. So at different angles, you are getting different angle of incidence and different angle of emergence here. But there is one particular angle that is 40 degrees where angle of incidence is going to be equal to angle of emergence, and that is called as angle of minimum deviation. So what is going to happen at angle of minimum deviation, I am going to discuss with you. Okay, so if you observe this diagram here, okay, so at this diagram, if you draw one line at the middle, this is called as law of symmetry works out here. You draw a middle line at this place. When this angle is going to be angle of minimum deviation, this is called as a middle line I have drawn here. So if you observe here, this is going to be symmetry. So at this place of symmetry, you will observe that I1 will be equal to I2. Okay, and R1 will be equal to R2. At what point it is going to be? At delta will become delta M. If delta is going to become delta M, that is minimum deviation, I1 will be equal to I2 and R1 will be equal to R2. So this is the identity you are getting. So from this, so let us go back to the previous concept here. So here, at angle of minimum deviation, that is delta equal to delta M, you are going to follow some steps here. What are the steps here? That is I1 will be equal to I2, let us consider as I, and R1 equal to R2, let us consider as R. So as these two angles are same, because of symmetry there, symmetry occurs whenever it is a case of minimum deviation. So let us see what is going to happen here. So at this place, you can just change the equations. Then equation 5 is going to become like this. So instead of R1 and R2, you are going to write R plus R is equal to A. So 2R is equal to A. R is equal to A by 2. Similarly, equation 6, if you observe, what it is going to be? So this is going to be I plus I is equal to A plus delta M, because our condition is at minimum deviation. So this is A plus delta M is equal to I plus I. So this can be considered as 2I is equal to A plus delta M. I is equal to A plus delta M by 2. So we got the value of I, we got the value of R also. So these two formulas are very important for us. This is I and this is R. Then finally, we are writing one formula according to Snell's law. So according to Snell's law, you know mu is equal to, that is refractive index is equal to sine of angle of incidence to that of sine of angle of refraction. It is a ratio actually. Sine of angle of incidence to the sine of angle of refraction. So I am going to write mu as sine A plus delta M by 2 divided by sine A by 2. Okay. So I think you are feeling a little bit bored because of this derivation. I'll discuss one classroom experience which I have experienced in my class because of problematic in some mother tongue influence. Because of some mother tongue influence, we are going to face some of the problems in life. Like for example, we try to convert our Hindi into English and we face a lot of problems. Once I was teaching the class and air was not coming inside because suffocation was there. Then I said to the students, open the windows, let the air force come inside, I said. The children opened the windows and suddenly children all are started seeing outside. I was wondering, useless fellows class is running and you are seeing outside. The children said, why are you seeing outside? They said, there's monkeys are there, sir. Monkeys are there, sir, outside. Okay. Then I thought of translating Urdu, Hindi into English. Like, मेरे रहते हुए तुम बाहर बंदरों को क्यों देखते हो? So, why are you seeing monkeys outside when I am here? They all started laughing. So this is called as mother tongue influence. Converting the sentence into English creates a lot of problems. For example, a person wrote a letter to his manager. He first thought in Hindi and tried to convert into English. He wanted to write a letter. Respected sir, मेरे घर में मेरे अलावा कोई भी नहीं, मेरी बीवी अकेली है, उसकी तबीयत ठीक नहीं है, मैं उसको देखभाल करने का है, इसलिए मैं कल ऑफिस नहीं आऊंगा. तो he tried to translate this into true English. Then the meaning is completely changing. He wrote the sentence like this: respected sir, my wife is suffering from fever. I am the only husband who has to look after her. So the meaning is completely changed. This is called as mother tongue influence. Sometimes we try to create more fun because of this mother tongue influence. Once a teacher was teaching, chemistry teacher was teaching. Suddenly periodic table calendar has fallen down. And after that, he was observing that nobody is lifting. He was totally irritated by this. And he thought of scolding the children in English. But first he thought in Urdu or Hindi. ये कैलेंडर कितनी देर से नीचे गिरा हुआ है, इसको ऊपर तुम लोग टांगेंगे या तो मैं टंगाऊं उसको ऊपर में. He tried to convert into English here. So what did he say? Useless fellows, your mother's father's manners this. You long hair, see this calendar falling down. Lift the calendar and hang to the nail. Otherwise, I will hang myself. तो कहना ये चाह रहा था कि मैं जाके लगाऊंगा. So meaning is changed here completely. So this type of problems I faced, which are very funny. Okay, so thank you. So let us go for the next topic here. That is refractive index formula we got now. Final formula is this one. So after understanding the final formula, let us go for the previous year problem which was asked here. So before going to this previous year problem which was asked there, so let us see what is going to happen here. If you observe this question, let us see what is going to happen. The refractive index of material of the prism is √2. Okay. An angle of the prism is 30 degrees. One of the two refracting surfaces. So what is the meaning of this question here? So if you understand the meaning of the question here, let us draw the diagram for this question and try to understand what he is going to explain here. So this was asked in 2018. It's a very simple question. Nothing there to worry. So this is going to be a prism according to the problem. So he said that this is a prism A, B and C. He's telling that the prism is having silvered at one side AC. So this is made up of, painting of silver is done on the one of the sides of the prism. He is telling that this is going to be normal, which I have drawn here, and he said that light ray is entering like this. So the light ray which is entering and it is going towards the other surface and it is touching the other surface which is silvered and is going to retrace back like this. It is going to retrace back. What is the meaning of retracing back? If this silvered surface was not present, light would have passed like this in a straight line. It is retracing back means exactly it is touching the other side of the prism perpendicularly. That is the meaning of this. So we have got some identities here which we need to discuss. So let us take this identity here, that is R1 plus R2 is equal to A. And another identity also we have discussed here, that is I1 plus I2 is equal to A plus delta. With these two identities we can solve this problem. And according to the problem, the light ray is striking one surface and retracing back. The meaning is it is going to strike the mirror exactly perpendicularly. That's why it is rebouncing back. So I can consider this as I1 and this as R1. So with this, what are you going to understand? What are I2 and R2? As it is going according to the problem, it is going along the normal. As the light ray is going along the normal, you will understand that I2 and R2 are going to be 0. If it would have come like this, then I2 would have gone some angle. But it is going along the normal if this mirror was not present. Therefore, I2 will be equal to R2 will be equal to 0. And he has given that refractive index of the prism is root 2 here. So what are you going to understand from this? So first identity is R1 plus 0 equal to A. And the question says that refractive index of the material of the prism is going to be root 2 and refracting angle is going to be 30 degrees here. Angle of the prism is given as 30 degrees and refractive index is given as root 2. How are you going to solve this problem then? R1 equal to A. That means R1 equal to 30 degrees according to the concept of problem given there. Then the next thing is, here as I2 is also going to be 0, you can write this as 0 I1 plus 0 is equal to A plus delta. But I think this is having no work with us now. We can solve the problem by using this concept only. So what is the general formula? This is not the case of minimum deviation. You just observe this problem. He didn't specify anywhere that it is having a minimum deviation. So this is a general case. We did not consider minimum deviation. So if you consider minimum deviation, again symmetry occurs. But he didn't discuss about minimum deviation. There is no chance of symmetry here. You have to write the problem here. Then according to Snell's law, here Snell's law general formula you have to consider. What is the general formula? Mu is equal to sin I1 by sin R1. Sin I1 by sin R1. That is going to be root 2. And I said here R1 is going to be 30 degrees. So you can write sin I1 by sin 30 is equal to root 2. So you have to write sin I1 is equal to root 2 into sin 30. That is root 2 into 1 by 2, which is going to be 1 by root 2. Because this 2 can be written as root 2 into root 2. Root 2 gets cancelled. This is going to be the answer here. Finally, sin I1 is going to be 1 by root 2 and the angle for that is 45 degrees. Okay. So for 45, 1 by root 2 will come. Therefore, we got the answer as I1 is equal to 45 degrees. So this is the answer for this problem. I think hope you understood nicely. So this is a prism concept in a very simple 3-step formula and the problem related to that. So our answer is going to be 45 degrees. Thank you very much and enjoy this session. Yes.